Hi, this is Ms. Fitzmaurice, and this video is about parallel and series circuits. So by the time this video is done, you should be able to identify parallel and series circuit elements, find equivalent resistance in complex circuits, and describe how the voltage or potential energy changes as electrons flow through parallel and series circuits, and you're going to be doing this with what's called the voltage divider method. Okay, so before I formally define parallel and series, I want to talk about how they're related to the lab that you did on Friday. So we had the two bright bulbs and the two dim bulbs, and if you remember, the two bright bulbs were connected to the battery so that each bulb was directly connected to the battery. So this is the light bulb connected to the battery, and they're both directly connected. And so they both kind of see the whole voltage of the battery. Okay, and this is an example of circuit elements that are in parallel. On the other hand, the two dim bulbs, one was connected to the battery on one side, okay, so this is our light bulb, and then it was connected to the second light bulb, and then it was connected back to the battery. And so the two light bulbs, they kind of split the voltage between them, and that is an example of two things that are in series. Now, there are all sorts of complicated combinations that would be in parallel or series, but to generalize them, elements that are in parallel are connected, I'm going to say elements in parallel, and I'm just going to write two lines to mean parallel, are connected to each other at both ends. Okay, so this is easier to see when I draw out a circuit diagram instead of the battery and the light bulbs themselves. So remember, this is our battery, and for them to both be bright, we have our two light bulbs, which are represented by this squiggly resistor line. And they're both connected to each other at each of their ends. Okay, and what that means in terms of voltage is that the voltage drop, or the change in voltage, or the change in potential energy, is the same for both. Okay. Now, if two elements are in series, then if an electron travels through one, so elements, not electrons, and by an element I could mean any kind of resistor. It could be a light bulb, a toaster oven, a hairdryer, but elements in series are connected so that if an electron goes through one, it has to go through another. Okay, Okay, so if you think about it, say that here is our positive side and here's our negative side of the battery. Our electrons are going through the wires, and if you go through one of your light bulbs, then to get through the battery, you have to go through the other light bulb. Okay? On the other hand, if you're an electron and you are in this circuit with our two bright bulbs, you have a choice. You can go through one, or you can go through the other to get back to the other side of the battery. You don't have to go the same, or you don't have to go through both. Okay, so what I want you guys to do is I want you to look at this circuit that I've drawn, and I want you to actually copy it down on your own page, and I want you to try to list out which circuit elements, A, B, and C, are in parallel with each other, and which one are in series. Okay, so remember that parallel means they're connected at two ends. And so you can look at this and you see that no two resistors are connected directly at two ends. But A is connected at two ends to B and C together. So what we can say, okay, if I am an electron and I went through B, I would have to go through C. So B and C are in series, they're one after another. And then you could say A is in parallel with, oh shoot, it paused. So A is in parallel with the series BC. Alright, so try this again. Now you have a much more complicated circuit. I want you to write down the circuit, and I want you to try to just tell me which elements are in series and which elements are in parallel. And then when you've done that, unpause the video for the answer. Okay, so if we look at D and E, they touch on two ends. Okay, so that's what I'm going to start off with. I know that D is in parallel with E. Okay, I can also look in B and C, and I see that if I am an electron and I have gone through C, in order to get back to the battery, I have to go through B. So I can see that B is in series with C. Okay. I can also say, I can kind of lump things together and treat them as a group. So if I'm an electron and I've gone through D and E, then I have to go through B and C. So I can say the parallel of DE is in series with B and C. Okay, and then finally, maybe you can see this, maybe you can't, but I see that I have kind of 2 points right here where I'm connected on both ends if I lump all of these guys together, and I'm connected on both ends to A. So what I can say is I can say that A is in parallel with, and I can give this whole big red circle that I just drew around the rest of them a name. I'm going to call it star, and I can say A is in parallel with star. So you're not just looking at individual elements, but you can kind of lump them together. Alright, so now that we've drawn out and identified parallel and series circuits, we're going to talk about finding equivalent resistance. And before I explain what that means, I'm going to do a really simple problem for you. So say I had this circuit right here. Okay, I have 12 volts, that's my battery. I have a 10 ohm resistor, whether that be a light bulb or your cell phone charger. And I want to know what is the current through this battery. Okay, last time I told you that the voltage is equal to current times resistance. So in this really simple circuit, you could go ahead and plug in the voltage as 12 volts. So the voltage is 12 volts. We are looking for I, and we know that the resistance is 10, so we can pretty easily solve for I. We divide both sides by 10, and we find that I is equal to 1.2 amps. Okay, but the question is, what would you do if instead of having that 110 ohm resistor, you had a slightly more complicated circuit, and each resistor is 10 ohms. So the question is, if you had this circuit with 3 resistors, each having a resistance of 12 ohms, if you wanted to use the equation V equals IR, what R would you put in? Would you put in 30 because you're just adding them all together, or would you have to do something complicated based on whether they were in parallel or in series? So to answer this question, we find some kind of equivalent resistance, and that's what I'm going to show you how to find next in the second part of this video.